All right, scientific notation, big and small numbers, it's like, well, I mean, okay, well, what is a big number? That's kind of relative to what you think big numbers are in comparison to small numbers. And, really, it's an argument that's fairly arbitrary because we could say that Earth is big, but it's really actually not, as you can see in the comparison of these other planets. And it's like, whoa, 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 hey, pump your brakes. I'm just like saying, like, planets are big, all right? That's a big number. And a small number is like, stuff you can't see, like a germ. That's small. So now that we got that straightened out, I just want to make sure that you understand what I mean by big and small numbers. All right. There's going to be some rules to this. Not really a big deal. It's a couple things to remember. So here's a super big number. I don't even know what number that is. That's how big that number is. But it's 1 with 3, 6, 9, 12, 15, 18 zeros. That's a lot. So that is light years away from Earth. So I mean, like someone could go, well, hey, Earth is 1 billion light years away from Earth, and you're like, what? So that's why exponents in scientific notation are used often to describe big things or really small things. You can see I got a planet there. Uh, if we're talking miles, like the distance from the Earth to the moon, that could be written in scientific notation just to give you context in a scientific manner. And then also there is an atom, and it's got its electrons and all that. Those are really small, and if you didn't know, you can't see those. And so those would use negative exponents, and they'd be describing an extremely small number. A way to remember what these things are doing is a positive exponent. Think about a number line going like this. You got positive numbers over here and you got negative numbers over here. That points the direction in which you move the decimal point. Super easy to remember. So like for example, 10 to the fourth, I'm going to go the positive direction 4 times. 1, 2, 3, 4. What do you think you put in those little blanks there? I'm going to move the decimal. You put zeros. So we have 53,500. So that's what this equals. Easy peasy. And then you got a -4. All right, -4 we know is going to go to the left. So I'm going to move it 4 times to the left. 1, 2, 3, 4. Now, I'm not even going to try to say the number because I would have to say it out loud and I'd get it wrong a whole bunch. And then you'd be like, does this guy even know what he's talking about? And I'd be like, I do, but like I've never had to go that many decimal places out. Anyway, that's what you're looking at. This number tells you the direction and how many times to move the decimal. In blank spots, you put zeros. And you're sitting there looking at this, and that's me going, uh-huh, right. What are you talking about? And I'm going like, dude, we got this on lockdown. So exponents introduction. You like how I spelled that? I know you do. I know you're looking at it and going, I appreciate how he spelled that. I want to go over this one more time because there are certain rules and things that have to be followed. For example, this first number in the format of scientific notation must always be greater than or equal to 1, which means it can't be less than 1, like 0.99 ain't going to happen. It can be 1.01, that would work. It's always going to be less than 10. So think about 9.3, okay? There's always going to be a multiplication sign. It'll always be multiplied by a base of 10. And the reason I say base of 10 is because this is called a power, whenever you have a big number and a baby number floating above it. And then you have this thing, it's called an exponent. It tells you how many times to use that 10. So really what's happening here is you're talking about it at 10. Here's a decimal point. 1, 2, 3, 4. And you're multiplying by 100,000. Okay, so what that's going to end up doing is moving this 1, 2, 3, 4, adding zeros. Decimal point's now over here. You've got 53,500. Okay? So the zeros tell you how many times to move the decimal point. That's also a shortcut for multiplying by a base of 10 at any point. So what I would like to see you do is go ahead and just like on a scratch sheet of paper, try this one real quick. Like you're thinking about, all right, what direction do negatives move? How many times do I need to move it? What am I putting in the blank spots? Cool. And then rewrite the answer. Notice I rewrote all of it. You can't just rewrite it where the decimal was, like 0.0002. You got to rewrite all the stuff that comes after it as well. So you can see this is what I'm talking about is a tiny number, and 53,500 is what I'm talking about is a big number, okay? So that's a number greater than 1, and this is a number less than 1. That's what classifies a big number in scientific notation. Basics. So talking about powers, just so we can understand what exponents are and what bases are. 3 is the base, 2 is the exponent. Together they make a power. This means you have 3 multiplied by itself 2 times, which means 3 times 3, okay? And if you know this already, that's fantastic. Never hurts to hear it again. This is just a review. So 9 to the 4th would be 4 9s getting multiplied. So just like instead of doing 9 plus 9 plus 9 plus 9, I think that was 4 of them, you could do 9 times 4. You can think of multiplication as a shortcut for addition, and you can think of powers or exponents as a shortcut for multiplying the same number over and over. 10 to the 5th, which is 10 times 10 times 10 times 10 times 10. Almost lost the meaning of 10. I said 10 so many times right there, but I think I still got it. 10. So here's the rules, and these are the things you're going to have to go over. First number must be greater than or equal to 1, yet less than 10. Easy to do. Always multiplied by 10. Base of 10. Easy to do. You'll have either a positive or a negative exponent, and that'll tell you if you have a big number or a small number. An exponent must be an integer, so you couldn't have like 10 to the negative 3.75, all right? Now, this is where the rational numbers vocabulary comes in, and we know an integer is any whole number, positive and negative, including 0. So negative 5, positive 7, negative 28, 1,552. Those are all whole numbers with their opposites, including 0. So is it in scientific notation? The reason I want to do this is because I want to show you examples and non-examples of something written in scientific notation and things not written in scientific notation. So for example, 4.25, is that in between 1 and 10? Check. Is it being multiplied by 10? Check. Is the exponent an integer? Wrong, it's not A. Okay, not written in scientific notation. Is this number between 1 and 10? Wrong. It's less than 1. Can't do it. But it does have a base of 10, and it does have an integer for the exponent. Is this number between 1 and 10? No, it is not. Wrong. But it does have a base of 10, and it does have an exponent as an integer. Is this between 1 and 10? Check. Does it have a base of 10? Check. Does it have an integer for the exponent? Check. This is written in scientific notation. Okay, and that would look like this, 4.25, and we have a positive 6, so 1, 2, 3, 4, 5, 6 decimal points now there. We're adding in zeros, and it looks like we've got 4,250,000. That would classify as a big number, okay? That coincides with the positive exponent. That's how you can always check. I got a big number. Is it a positive exponent? Check, check. All right, good. Okay, so I'm going to throw some Spanish in here. And yeah, I took a lot of Spanish class in school, and I actually speak quite a bit. But that's not the point. I was just, I'm just trying to spice things up, right? So, I mean, don't hate on me for that. All right, so is the number small? So this is kind of think about working backwards. Right now, we don't have scientific notation. Right now, we have standard form or standard notation, which is just you looking at a number, right? So this is just a regular old number. Now the question you're going to ask yourself, is this a small number? And you're going to go like, yeah, that's got a decimal point followed by a whole bunch of zeros. Sweet. So we know that we're going to have something times 10 with a negative exponent, okay? Because we know that small numbers have negative exponents. Now all you have to do is count how many times you move the decimal point to where it passes the first whole number, okay? So look, 1, 2, 3, 4, 5. There's the first number. Boom, 6. The decimal ended up between the 2 and the 5, so 2.56 times 10 to the negative 6th. Let's take a look at it again. Is this a tiny number? Yeah. Mr. Foster, that's a tiny number. It's got a decimal point followed by a whole bunch of zeros again, like you just asked that. And it's like, God, you're such a teenager. All right, so we know it's going to be a negative exponent. Now all we got to do is find the first number that's not 0, and then we're going to put the decimal point immediately after that one. And the reason I say that is because 100% of the time it will end up being a number between 1 and 10 if you pass the first whole number. If you pass 2 of the first whole numbers, you're going to be in double digits. That's not in between 1 and 10. 1, 2, 3, 4, 5, 6, 7. All right, so we know we moved it over 7 times. It looks like we've got 1.4 times 10 to the negative 7. That was a tiny number. We have a negative exponent in between 1 and 10, base of 10, integer. In between 1 and 10, base of 10, integer. And yes, you're like, okay, it's small. Don't even go through the whole thing again. Got it. Times 10 is going to be negative, okay? 1, 2, 3, 4. 2.75 times 10 to the negative 4th, okay? So let's go ahead and say that we've got big numbers. Let's say 222,000, okay? Is it a small number or is it big? All right, well, we got a big number, so we know we're going to be doing times 10 to a positive, okay? I'm just going to put a little box there. That way we know we have to put something. If you don't see a decimal in a number, it's always located at the end, okay? Now all we got to do is go the opposite direction, and we have to make it to where there's only one number left. Make it in between 1 and 10. So here's where we would go. It's a big number, so we know 1, 2, 3, 4. That's not in between 1 and 10, 22.2. Right, so 1, 2, 3, 4, 5. 2.22 is in between 1 and 10. That is 5. Okay? So you can see where the only number that's left on the left side is the first whole number. Interesting. It's got something to do with the first whole number all the time. So this is a big number. It coincides with the positive exponent. Por ejemplo. So, here's where the assignment begins. But before we begin, before I give you the assignment, I want to go over exactly what I want the work to look like. This will tell me if you know exactly what's going on. Then I'm going to reverse it on you and just flip it all upside down and see what you can do there. You should be able to work this backwards and forward, go to standard form, scientific notation to standard form. It's not a big deal. It's pretty easy to do. You just need to practice. So there are 3 links that are going to be included in the email. And this is the one I emphasize the most. It's the most boring, but it's the one that also lets you practice. It has a timer, so if a timer bothers you, don't do that until you feel comfortable doing that. This is one that will convert back and forth. That way you can go standard to scientific, scientific to standard. And this is just an overall review of all the vocabulary, all the nuances of scientific notation. All right, stop talking, dude. So here's an example of 2 problems that will be for your assignment. Now what I want you to do is I want you to be able to go like this. I want you to write it down. So we can't skip any of these steps. I want you to then put times 10, and I want you to put a negative, okay? I want you to be able to interpret. Then I want you to be able to show me that you're moving the decimal point. If I'm not seeing these little wavy things, you're not doing what you're supposed to be doing. Pass the first whole number, 2.16. 1, 2, 3, 4. Box it in. If you want to check it, work it backwards. Use your answer to recreate. Okay, so this is what I encourage you to do, but this is the part that I'm not going to make you do. So negative 4, it's going to be a small number. Negatives go to the left. So 1, 2, 3, 4, 0, 0, 0. Cool, it matches 0.000216, 0.000216. Just check my work, okay? These are the things that can be done. You'll never get these wrong over and over and over. It's impossible if you do this method. Let's go through a second one just to make sure. 0.0042. Is the number small? Yes. We know we're going to have a negative. So let's move it past the first whole number. 1, 2, 3, 4. Okay, so 4.2, we moved it 3 times. Problem's done. What if I want to check that thing? Well, it would look like this. Negatives go to the left. So 1, 2, 3, 0, 0.0042, 0.0042, check. It's impossible to miss these if you check them, all right? Because you're coming up with the alternate answer to it. So ultimately, you should be able to get all of them right. If you have any problems with this, please contact me. We can set up a meet. We can go over it individually, completely fine. But I just want to throw it out there with instruction, see what you can do with it. Go.